Hello everybody, I'm Professor Abdul Karim from University Science Malaysia. In this lecture, I will talk about edible oil refining, and the second part of the lecture on this topic. So I will discuss in more detail about the physical and chemical refining process of crude palm oil. This diagram shows the various stages in the refining of crude palm oil. So let's start from this point. This is crude oil. It will pass through a heater or a heat exchanger. The oil will be heated to increase the temperature and reduce the viscosity so that it can flow easily through the processing line. And at this point, some reagent will be added for degumming process. So this can be in the form of phosphoric acid or citric acid. If we use acid bleaching or acid degumming, or we can also use hot water if the oil contain hydratable phosphatides. So the gums or the phosphatides will be removed at this stage in the degumming process. Usually high-speed mixer is required here to mix the oil and the reagents intimately and uniformly. Then the oil will go through the next step. In a chemical refining process, the next step would be the neutralization process, where the sodium hydroxide or the alkali will be added, and this will react with the free fatty acids, and the gums will be formed here. So we have the oil and the gums together formed during the neutralization process. So we need the centrifuge to separate the oil from the gums or from the soap. The next step in the process is bleaching. So bleaching, the function of bleaching is to remove the coloring compound and other compounds like ketones, aldehydes, trace metals, and so on. So we add the adsorbent in the form of bleaching clay or bleaching earth, and the process is done under vacuum and elevated temperature to reduce the color of the crude oil. And after the bleaching, the oil will be pumped through a series of filter to separate the oil from the adsorbent material, and perhaps some polishing step to ensure the bleaching earth, the spent bleaching earth particles will be removed completely. Because the next step is deodorization. So before the oil goes through the deodorization process, it's very important to make sure the oil doesn't contain any residual bleaching earth or soap from the previous step. So here we have a high pack column, which is the distillation column to deodorize and to remove the free fatty acid and the volatiles from the oil, and the volatile material will be recovered as distillate, and the oil will be recovered as RBD oil, which is a refined bleach deodorized oil. Let's look at more detail on the degumming process. Degumming basically is a process to remove the gummy material or mucilaginous material from the crude oil. These are basically phosphatides in the crude oil. So we can use water or dilute acid in the form of phosphoric or citric acid, or sometimes dilute sodium hydroxide. There are actually two types of phosphatides. One is called hydratable phosphatides, which can be hydrated by using hot water, and the other one is non-hydratable phosphatides, which can only be removed by using acid. So for example, soybean oil contain high amount of hydratable phosphatides. So we can use hot water to remove the gums, and the hydrated gums that we remove from the soybean oil actually can be used as a raw material for lecithin processing. So for water degumming, these are the conditions: the temperature between 60 to 80 degrees Celsius, and the time between 20 to 30 minutes. And the wet gums that are formed can be removed by centrifugation. As I mentioned in the previous slide, we can use water degumming if the crude oil contains high amount of hydratable phosphatides. But if the oil contains non-hydratable phosphatides, we have to use a concentrated acid to remove the phosphatides, and this process is called acid degumming. So we can use phosphoric acid between 0.1 to 0.3% of the 85% solution, or we can use citric acid with this concentration. The degumming step is actually especially very important in physical refining. So we need to remove almost 100% of phosphatides, and this process is called super degumming to prepare the oil before it goes through the physical refining. This diagram shows the various stages in water degumming process. Water degumming is suitable if the oil contains high amount of hydratable phosphatides, for example, soybean oil. So the crude oil will be pumped through the heat exchanger to heat up the oil to the optimum temperature. Then after that, the hot water will be added to the oil. The amount of hot water added is calculated to be equivalent or correspond to the amount of phosphatides in the oil, and it will go to the centrifugal mixer here, and will be because of the intense mixing, the phosphatides will be hydrated very fast, and after that it will go through the centrifuge or the separator to separate the oil from the gums. The oil can go directly to the next refining process, or alternatively, if the oil is to be stored for some time, it will go through the drying process in the vacuum dryer to remove the water as much as possible, because we cannot leave the water inside the oil because it can cause hydrolysis. So the final step, the final product at the end of the degumming process is the degum oil. And the picture down here is the separator, how the separator looks like. And this diagram shows the various stages in acid degumming process. Acid degumming process is suitable when the oil contains significant amount of non-hydratable phosphatides. Acid degumming is commonly used for our palm oil or palm kernel oil in the refining process. So the crude oil will go through the heater, and the acid in the form of phosphoric acid will be added at this point and mix with the oil, and it will go to the holding tank, and the next step, the hot water will be added to hydrate the hydratable phosphatides in the oil. Again, mix and go to the holding tank, and before it will go to the separator to separate the gum from the oil. And again, if necessary, the oil will be dry in the vacuum dryer, and finally we get the degum oil, which is ready to go for the next step, which is the bleaching step. If we use chemical refining to refine the crude oil, so there's a step called neutralization, where we will add the alkali to neutralize the acid or the free fatty acid in the crude oil. So the purpose of this step is basically to remove almost all of the free fatty acid present in the crude oil down to a very low level, typically below or to between 0.01 to 0.03%. Usually in the crude oil, we have between 3 to 5%. So you can see there's a large reduction of free fatty acid during the neutralization step. The concentration of sodium hydroxide used in the neutralization step is between 8 to 24%. This concentration will depend on the type of oil and also the initial amount of the free fatty acid. So the alkali will react with the free fatty acid to produce the soaps, which is insoluble, and it's called soap stock, which can be removed by the separator or by centrifugation. So basically there are 3 steps in the neutralization process. The neutralization itself, when we add the alkali and to the oil, then we remove the soap, separate the soap from the soap stock from the oil by using centrifugation. But after that, there's probably some traces of soap which can be removed further by washing step, and finally drying to remove whatever moisture is still there down to a very low level, around 0.1%. This diagram shows a general outline of standard neutralization in the alkali refining, but the actual process will depend on the type of oil and the amount of gums or free fatty acid in the oil. For example, some oil may require some conditioning. So basically, depending on the amount of gums and free fatty acid, it may require some pre-degumming step. Then the alkali will be added. So this is the neutralization step here, and the separator will separate the soap stock from the oil, and the oil might contain some residual soap stock, so it will require probably a few steps of washing and maybe even refining. So the quality control would determine whether how many washing steps or whether re-refining is needed, so that the final oil will contain very low amount of free fatty acid, and maybe drying step is also required to bring down the moisture to around 0.1%, and finally we get the neutralized oil. So this is the picture of separator which used in the neutralization or degumming process to separate the heavy layer of the sediments from the lighter phase of the oil. Another major step in crude oil refining is bleaching. As we have seen in the previous lecture, crude palm oil has a dark orange or dark red color. So in the refining process, the aim is to remove this color by removing the coloring compound, which is keratin and chlorophyll, by using a suitable adsorbent material. Bleaching is also the last stage prior to deodorization process. So it is important to remove any residual phosphatides from previous degumming process, maybe residual soaps from the previous neutralization step, any residual metals and oxidation products. This has to be removed almost completely prior to deodorization process. Originally, natural bleaching clays were used as an adsorbent in the bleaching process, but nowadays acid-activated bleaching earth are used with higher adsorptive, catalytic, and ion exchange properties. So this picture shows the bleaching tank. This is how it looks like. In the bleaching process, the bleaching earth or the clay is added at around 0.3 to 0.6%, and usually the process is done under vacuum to reduce damage to the oil, because we use a high temperature around 100 to 110 degree Celsius. The last step in the edible oil refining is called deodorization. In alkaline refining, deodorization is a last step to remove any residual or traces of free fatty acids which may survive from the previous step, and also to remove aldehydes and ketones which are more volatile than the triglycerides of the oil. In physical refining, deodorization is the most important step to remove the free fatty acid. The high temperature during the deodorization also would decolorize the oil because it will decompose the pigments in the oil. So the final deodorized oil actually will be bland and odorless. The process of deodorization is basically a steam distillation done under vacuum. So it is very important during this process to get a very intimate mixing of the steam and the oil, as well as the vacuum and the temperature. The control of these parameters are important to get an efficient deodorization to remove the free fatty acid down to a very low level, less than 0.01%. So how does these different components such as free fatty acid, tocopherol, and other components can be separated with oil during the deodorization process? So the principle is actually based on the different degree of volatility of the different components when compared to oil. So we can see here, this is a plot of vapor pressure against different temperature. So we can see for the oil, it requires high temperature to make it volatile, whereas free fatty acid, which are the smaller compound, are more volatile even at lower temperature. So the different degree of volatility at different temperature enable this different component being separated from the oil. So let's look at some of the typical conditions during in the deodorizer during the process. The typical conditions you can see here, the pressure. So it is very low pressure. So the process is done basically under vacuum. Then the temperature is very high, between 230 to 200 degrees Celsius, and the time between 3 to 8 hours for batch deodorizers, or for semi-continuous and continuous deodorizers, much shorter, between 15 to 60 minutes. So in the deodorizer unit, steam is sparged into the deaerated oil. The oil is deaerated to remove the air, so that it will reduce the oxidation, especially at high temperature in the deodorizer. And the steam will come in the intimate contact with the oil. So as the oil passes through several trays or compartments in the deodorizer, the volatile components are stripped away by the steam, and then separately condensed and collected as the fatty acid distillate. And next, the deodorized oil will be cool when it leaves the deodorizer. Okay, now let's look at more detail on the deodorizer unit. These are the schematic diagram to show the structure of the deodorizer column. And on the right here, this is how it looks like from the top of the deodorizer column. This actual thing, how it looks like from the top. So basically the oil comes from the top into the column, and will go through several stages of stripping of the volatiles when it comes to with the in intimate contact with the steam, and finally it will come out here as the deodorized oil. So On the top part here is the aerating tank, where the oil will be the air in the oil will be removed. So the aeration process remove the air, so that it will reduce the oxidation of the oil during the deodorization process. Then we have the heating tank here, and the steam is being sparged inside, and the stripping of the free fatty acid and other volatiles will take place when the oil flows through the column in the deodorizer. So during this process, the steam that is will be sparged into the deodorizer unit and will come into intimate contact with the oil, and the high temperature and the vacuum condition will allow the volatiles to vaporize into the large headspace vacuum space here, and will be removed and collected as distillate. Phosphoric or citric acid may be added as chelating agents into the deodorized oil to deactivate any trace metals that may still be present at this stage. So the end product of the refining process after the deodorization step is called refined bleach deodorized oil, or RBD oil, and this is usually marketed as cooking or salad oil, or can be used for manufacturing of other types of oil products. And the volatile components during the deodorization process are removed as condensate, and this actually contain various compounds, and this is called deodorizer distillate, and this can be further separated into tocopherol and sterols for various application in pharmaceutical and cosmetic applications. Okay, in this slide it just show a picture of the deodorizing plant, and another one here showing the deodorizing plant from the inside the factory. Okay, so far we have discussed the process of chemical refining of crude palm oil. So now let's discuss briefly the physical refining. So on this slide, this is actually the outline of the process of physical refining or physical refining plant, and the outline shown here is for the Alfa Laval AB, which is the one of the major manufacturer of physical refining plant in the world. So the starting point here is the crude palm oil. The crude palm oil is stored usually in a large tank under nitrogen gas to minimize the oxidation. And next is the degumming step. In physical refining, degumming is a very important step to remove the gums from the oil. So usually we use acid degumming process, and the process is done under reduced pressure, and the steam is used here to elevate the temperature to aid the degumming process. The next step is the bleaching process as shown here. So the oil is mixed with the steam, and bleaching earth or the bleaching clay is added to absorb the coloring compound, the aldehyde ketones, and the trace metals in the oil. And at this point, after the bleaching process, the color of the crude oil will be reduced significantly. From the bleaching tank, the bleach oil will be pumped through a series of filter to remove the spent bleaching earth, and this step is very critical to remove the insoluble particles from the oil before the oil is pumped to the deodorizer unit. So at this point, there is a stage of deodorization where the free fatty acids and other volatile compounds are removed from the oil, and the fatty acids are recovered. Then finally we get the refined deodorized palm oil.